Hello guys, welcome back. So in today's lesson, we are breaking down trigonometry, Maclaurin series and integration. And this one builds real exam confidence. Okay, this was a question from ZIMsEC November 2005, paper 1. Number 15, it reads, given function of x equal to tan x, where x is not equal to all multiples of 2n plus 1 pi, by expressing f of x as sine x over cos x, show that first derivative of x is equal to 1 plus tan squared x. Item 1, obtain expressions for the second derivative and the third derivative. 2, show that the Maclaurin series for tan x is x plus x cubed over 3 if x is small enough for the terms in x to the fourth and higher powers to be neglected. 3, state one reason why Maclaurin series for cot x cannot be obtained. Then B, find the exact value of integral from pi over 4 to pi over 3 of tan squared x dx. Okay, guys, let's get the ball rolling. All right. We are told that we have to express tan x. So here, right, so f of, this is number 15. Right, so number 15, f of x equal to tan x, which is equal to sine x over cosine of x. Right, so we are going to let u equal to sine x. If we differentiate u, we get cos x. Then and v equal to cos x. If we differentiate that, we get negative sine x. Right, so our first derivative here, we're going to, since it's quotient rule, it's going to be v du minus u dv over v squared. So it's going to be v, which is cos x du, that's cos x, minus u, which is sine x, times negative sine x over cos squared x. Right, here it's going to be cos squared x plus sine squared x over cos squared x, which is 1 over cos squared x, right? But we know that 1 over cos squared x is sec squared x, right? So now, guys, suppose you're in the exam, maybe it's not provided in the formula booklet. Remember this. Sine squared x plus cos squared x equal to 1. Since you want it to be in terms of tan, we are going to divide by cos squared x, cos squared x, cos squared x. So here, tan squared x plus 1 equal to sec squared x. So this is very important. Right, so now it's one of the Pythagorean trigonometric identities. All right, so here it's now tan squared x plus 1, right? We have proven that it's true. Okay, so now we have item 1. So item 1, we have to express the second derivative and the third in terms of that. So now we know that our first derivative here is equal to tan squared x plus 1. So to get the second derivative, right, now we are going to use power. So we're going to bring down the power, then we differentiate the trig, then the algebra. So if we drop down, it's going to be 2 tan x. Then if we differentiate tan, it's going to be this one, with 6 squared, which is just tan squared x plus 1 when expanded is 2 tan cubed x plus 2 tan x. So that's the second derivative. And now to get the third derivative, again we're going to bring down, so we have 6 tan squared x. Then if we differentiate tan, we get that tan squared x plus 1. Remember, we get 6 squared, right? Then plus 2. If we differentiate tan, we get 6 squared, which is tan squared x plus 1. When expanding, I get 6 tan 4x plus 6 tan squared x plus 2 tan squared x plus 2. And now if I combine, I will have 6 tan 4x plus 8 tan squared x plus 2. Right. So that's these are the derivatives for the second and the third, or these are that's the first, second, and third derivatives, right? Okay. Now we have to, on item 2. So item 2, right? If x to the fourth and higher powers are to be neglected, we need to show that the tan x is equal to x plus x cubed over 3. No problem. Our function of x here is equal to tan x. So what it means is that f of 0, right, is equal to tan 0, which is just 0. F prime of x, I think for f prime of x, it was 1 plus tan squared x. So f prime at 0 is going to be 1 plus tan squared 0, which is just 1. F prime prime at x, the second derivative, for the second derivative, I think we got 2 tan cubed and 2 tan, okay. So it was equal to 2 tan cubed x plus 2 tan x. So it implies that f prime at 0 is just 0, because it's 0 plus 0. Then f prime prime at x is equal to, so it is that one, 6 tan to the 4 of x plus 8 tan squared x plus 2. So it implies that f prime 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 at 0 is just 2, because these are zeros. Now we know the formula, right? So the formula, f of x is equal to tan x, which is equal to f of 0 plus f prime at 0x, right? Sorry. Right, plus f prime at 0 times x plus f prime prime at 0 x squared over 2 factorial plus f prime 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 at 0 x cubed over 3 factorial, right? So now if I plug in, right, these values, you see the first one was 0 there, right? 0, 1, 0, 2. So it's now 0 plus 1 times x, right, plus this one, I think it was 0, right, x squared over 2, right, then plus 2 x cubed over 3 times 2, which is just x plus x cubed over 3. And we are done. Right, this is exactly what we should show. Okay, then item 3, item 3 says, state one reason why Maclaurin series for cot X cannot be obtained. Guys, I need to bring this to your senses or to your attention. So cot X is equal to cos X over sin X. So this implies that when I say cot 0, is going to be cos 0 over sine 0. Cos 0 is 1 over 0, and it becomes undefined. Right. So here it's leave, if we find Maclaurin of cot X, it becomes undefined, since we cannot define, we cannot divide by 0. I think that's the best answer. So at x equal to 0, it is undefined. Just say at x equal to 0, it is undefined. Right. Okay. That's all. Now we have the last one. We need to find the exact value. So guys, when they say find the exact value, we are supposed to leave the answer in its precise mathematical form with no rounding or approximations. If it's pi, you leave it in terms of pi or in terms of radical or even as a fraction 1 over 2, not as decimals or whatever. Right. So we want to find the integral from pi over 4 to pi over 3 of tan squared x dx. But guys, remember, we don't have a direct integral of tan squared, but we have that relationship. If you still remember, we had a relationship sec squared x equal to 1 plus tan. Okay. Sec squared x is equal to 1 plus tan squared x, which implies that sec squared x minus 1 is equal to tan squared x. So this is what we are going to use, right? So now we are going to integrate from pi over 4 to pi over 3 sec squared x minus 1 with respect to x. So if we integrate sec squared, right, we must get tan. Remember, when we differentiated tan, we got sec squared. So now if we integrate sec, it's now the opposite. So we're going to get tan x minus x. Then our limits are from pi over 4 to pi over 3, right? So it's upper limit minus lower limit. So it's going to be tan pi over 3 minus pi over 3, subtracting tan pi over 4 minus pi over 4. So tan pi over 3, which is tan 60, should be root of 3. So it's square root of 3 minus pi over 3 minus 1. Right, tan 45 is 1, then plus pi over 4. So let me simplify negative third plus a third. Okay, so negative a third, okay, negative 1 over 3, right, plus 1 over 4, it's negative 1 over 12. So the answer is square root of 3, right, minus 1 minus pi over 12. So that's the exact value here. So guys, that's how we solve this problem. And please don't stop here. Remember, mastery comes with practice. I'll see you in my next video. Take care.